know could be in quadrant 1 or 4. It's a negative, it's quadrant 4. Reference angle, when is tangent 1? 45 degrees, or pi over 4. Pi over 4 in quadrant 4, double minus 1, 7 pi over 4. Or you could say negative pi over 4. That would be the same. Tangent inverse of radical 3. Tangent inverse can be 1 or 2. Sorry, 1 or 4. It's a positive, so we're in quadrant 1. Reference angle, when is tangent radical 3? That would be at 60 degrees, so pi over 3. And pi over 3 in quadrant 1 is pi over 3. And secant inverse of negative 2 radical 3 over 3. So secant is a reciprocal of cosine, so it exists in 1 and 2. Negative, so quadrant 2. Reference angle. If you need to, think about cosine is the reciprocal. So cosine's radical 3 over 2. So if cosine's radical 3 over 2, that would be at 30 degrees, so pi over 6. And pi over 6 in quadrant 2 is 5 pi over 6. Make sure that you are not trying to rely on a calculator for these questions. These are unit circle type questions. I should be able to expect you to do them without a calculator on those. All right. Any questions there? Then let's go ahead and finish our notes. We only have 2 examples left. So like I said, I'm going to finish this. I am going to introduce the next section today. I can give you a little time to work on the homework in between if you want. So the homework from yesterday is due tomorrow. When I look at these, it does say without a calculator. So just put that away for a moment. We know if you were just going to start working this, you would have to start on the inside, right? Tangent inverse of 3/2. An inverse is finding an angle. Do we know the angle when tangent is 3 over 2? No. So I'm telling you, you can't use a calculator, but it's not one we have memorized. However, we can still get it. If we think about this for a moment, when I say tangent inverse of 3/2, I'm basically saying tangent of what angle is equal to 3 over 2. And then, once I find that angle, we have to do sine of that angle. Tangent inverse can be in which quadrants? 1 and 4. Since 3/2 is positive, it's in quadrant 1. Okay. I did a triangle. Here's my angle. Tangent is opposite over adjacent. If I know 2 sides in a triangle, how do I get my third? So this side is the square root of 13. Okay, I still didn't find my angle. But can you do sine of this angle? Yeah. Once we have a triangle set up, we know SOHCAHTOA. Sine is opposite over hypotenuse. So 3 over the square root of 13. Or if we get the radical off the bottom, 3 radical 13 over 13. So if you're doing both an inverse and a trig function together, you don't ever actually have to figure out the angle. You just use the information to set up a triangle. What questions do we have there? So if I look at this one, again, I don't know this angle, but what that means is cosine of some angle is equal to negative 5/13. And we have to find tangent of that angle. Cosine inverse can be in which quadrants?
1 and 2.
Which one is this going to be in? 2, because it's a negative. Okay. Cosine's adjacent over hypotenuse. Which one gets the negative? The adjacent. So Pythagorean theorem. Would this side be positive or negative? Positive since it's going up, so that is 12. So tangent, opposite over adjacent, 12 over negative 5, or negative 12 this. Any questions? Okay. Why don't you guys take a few minutes and work on that assignment from yesterday and see if we have any issues with it. And we'll spend a couple days on it. So. And then, like, we'll be done with chapter 6. We're only doing 3 sections of it. So. I know, that's getting exciting. Okay, this is a little bit different. We are solving equations with trig functions. So, it's very similar, yet not at the same time. The problems you just got done doing, all of them had inverses in the original problem, which meant we could only get a single answer. The equations we're going to be solving, we're still finding an angle, so it's thinking like an inverse. But if the original problem doesn't have an inverse in it, we are thinking about every time on the circle that happens. So for example, if I ask you to solve the equation 3 tangent of theta minus the square root of 3 equals 0. Don't worry about the 2 separate directions right now. I'll explain that in a minute. Let's just solve this. So if you want to get tangent by itself, what would you do? Okay. And then? Okay. This does not say tangent inverse. So I'm not saying, or I'm not limited on my answers. Now I'm thinking about regular tangent. In which quadrants is tangent positive? Reference angle. When is tangent radical 3 over 3? We are in degrees. 30, right? Radical 1 over radical 3. So part A is just giving those 2 degree measures. In quadrant 1, 30 degrees is 30 degrees. In quadrant 3, 180 plus 30 is 210. So those are the 2 times just between 0 and 360 that this would be true. Is everybody okay with that? All right. B, I said for all possible solutions. So think about our circle. All right, we said it happens at 30 and 210. But what happens if I go around my circle again? Will it also happen at 390? And again, right? There's no stopping point. How many degrees does it take to get all the way around my circle? 360. So if I say all possible solutions, obviously we can't write them all, but we just have to show that we're looking at every multiple. So we do our 2 solutions, and I'm going to say plus 360k. Okay, you can pick whatever letter, but k is just an integer here. So it could be once or twice or three, or I could go backwards, 1 or 2 or 3 or however many times. I do the same for the 210. So if I'm asking for all possible solutions, we're just adding that 360 degrees with a variable to show every multiple of 360 we're going to have a solution again. Is that one okay? Let's do another one. I'd like to do 3 examples and I'll be probably done for today. All right, what would I do to solve this one? Divide by 2, so sine is -1/2. Okay, it's not sine inverse, so regular sine. In what quadrants is sine negative? Reference angle, when is sine 1/2? Okay. So my answer is between 0 and 360. My angle could have been 30 degrees in quadrant 3. So we have to think 180 plus 30 is 210. In quadrant 4, 360 minus 30 is 330. I also asked for all possible. How do you get all possible? To each of them. And you do need to specify that k is an integer. Is that okay? Let's do another one. All right. This one's definitely not as easy. Don't just have a single trig function. But think about if I gave you a problem with like x squared y equals x, and I told you to solve for x. What would you do first?
Divide by x.
Can we divide by it though? Because what if it's 0, right? We can't divide by it, but we would bring it over, and then what could you do? Factor out. That's what we're going to do here. We can't divide by a trig function because it's possible that cosine is 0. But I can bring them to the same side. I have 2 terms. Both of them have a cosine theta, so I can take it out. Now I just have 2 things multiplied that equal 0, so we have to solve them. Okay, I need to know when cosine is equal to 0, or when cotangent theta plus 1 is equal to 0. All right, every time on the unit circle when cosine is 0, think about cosine is your x value. When is x 0 on the unit circle?
90 degrees and 270 degrees.
Mm-hmm. Okay, this one is saying cotangent is -1. In what quadrants is cotangent negative? Think make all students take calculus. It's positive in 1 and 3, so it's negative in 2 and 4. Reference angle, when is cotangent 1? Or that means tangent is 1. When does that happen?
45 degrees.
So 45 degrees in quadrant 2, 180 minus 45 is 135. Quadrant 4, 360 minus 45 is 350.